Welcome, everyone, fellow tech survivors, to this video discussing and teaching and talking about how we'll deploy a Kubernetes cluster on our local workstation. And the tool we're going to use to do this is called KinD. It stands for Kubernetes in Docker. So if we search here, search Google quick, KinD Kubernetes cluster. So here's the link to this open source tool. I like this tool for testing anything that needs to run in Kubernetes on my workstation because it handles most local use cases. And the reason is most of our local testing and stuff like that don't require the demonstration of, like, say, multiple clusters to possibly demo maybe multiple region. Those are a little bit more advanced. We will be doing those, but we're not doing those here today. So as you see, I'm going to the GitHub. There will be a link in this down in the video, in the metadata about the video here. But to show everybody watching, the organization that we're using everything for is Tech Survival School, and then here we have a KinD repository here. So to get started, we're gonna go here and check this out. So this is the simplest diagram that we'll probably ever have in Tech Survival School, because it's just basically showing what all we have on our workstation. So the way KinD works is it's going to use a backend container. Can't even think of the word. Container runtime engine, a backend container runtime engine. So the container runtime engine we'll use for this is Docker. So one of the dependencies is Docker, and you do need to have Docker installed. So we do have Docker installed here, but Docker is not running currently. One of the things you can test is once you open up your terminal here, and if you're on Windows, go ahead and search for terminal on here, or if you're on Mac, you can go in the apps location under tools. There should be a terminal there. If you're on a Mac, I recommend terminal 2, iTerm 2. So if you're on a Mac, I recommend you go ahead and grab this terminal. This terminal is much better than the one that Mac ships with. But beware that it's going to, I think it points you to a different shell now. The default shell is something else. It's not bash. If you want bash, you got to go ahead and modify your Mac user. So for Windows, you'll just go ahead and use, you can just go ahead and use the PowerShell here. What I like to do is after I pin this to my taskbar here, I like to hold down the Shift key and I like to run, I like to run it as, it's going to do it for me now. It's not going to do it now because I have it open. Let's go back. So if I hold down the Shift key and I don't have it open, I can click Run as Administrator, and that'll come up here for me. And I need to get into the Tech Survival School here because we're going to clone this repo. So we're going to run our Kubernetes cluster. What's going to happen is Docker is going to be running in the background here. So what I was saying before is if I do a Docker PS, for example, we're not going to get anything back. Let's see if I can make this a little larger. There we go. Control. That's what it is. Okay, I want to make that a little larger for the screen. If that is going to behave. Okay. So we can't communicate with the Docker runtime right now, the Docker runtime engine right now, because it's not running. I just rebooted my workstation. So usually when workstation comes online and you have Docker in the background, most of the time it's not going to be starting up automatically. You can try to get it to do so. I've had various levels of success with that, but it's just fine with me that it doesn't start right away because I don't necessarily need, you don't necessarily need all your containers running right away all the time once you're starting your local workstation for something. So right here, so I'm just going to fire it up right here. It'll take a little bit to start up. It may have a running container from the previous session. I was working on some other things before. Let's take a look. And there are no running containers. So now we should get something back. So there are currently no running Docker containers at this time. Now, let's go ahead and clone this repo, but before we do, I just want to finish discussing this. So what's going to happen is this node here is going to be a running container image, and this container image is going to be downloaded from the repository in Docker that KinD has set up. So KinD has created a container image just for this, for running Kubernetes clusters on Docker on a container runtime engine, and you can have multiple nodes. For example, you could have a master with a control plane, then you can have some worker nodes and stuff like that. We're not going to be using multiple node clusters in tech survival school for a while because the issue has to do with networking. Okay, in order to for one thing, if we were going to do that, we'd want to be able to create a more of a true representation of what we find in the cloud, what we find in actual production environments. That's the whole reason for doing some things on our workstation. We want to get enough of an environment up that represents certain things, components and stuff like that, so that we can test things, we can break things, we can fix things, so that we can find out in much greater detail how things work. And that's why we're doing this whole thing. So this Kubernetes cluster on our local workstation is very fast. It's going to bring up a Kubernetes cluster, and then we'll be able to start deploying things to it. Okay, so that's the diagram. It's the simplest diagram we're going to have. Okay, so let's go back to code here. I don't know why I was seeing that. That looked a little strange. Okay, so the way we're going to clone this is, so you just go to the main repo here, Tech Survival School KinD after GitHub. We go to code here. There's a button here you can click to copy the URL. And then you do need to have Git installed. Okay, so you can install Git. If you're on Windows, I recommend you use the Chocolatey package manager for Windows to install things with command line. If you're on Mac, go ahead and use brew, the homebrew package, and then you can do brew install Git, or you can do choco install Git. So we have Git here, so I say Git clone. And I'm just going to paste in the URL there. Okay, so now we have a KinD directory here. And then so we're going to change directories into that. We're going to look at the contents here. We have everything there. So once we're inside this folder here for Git, we're going to go to Git status to see what kind of branch we're on. We're on the main branch, the main default branch that comes down. So the main branch consists of just these files, some images, which has this diagram in here, and then this image of KinD that I wanted to throw up there. And that's it. That's all it has. And then it has links here to these two different deployment shells. So if you're on a Mac, you can use Bash, and if you're on Windows, you'll use the PowerShell. So use the PowerShell. Go in here. We have the instructions here. So this is just setting the location. This is going to put us in the home directory. You can skip this command if you already have your specific location that you want this cloned. You don't have to set this. This is just essentially saying change directory home. And then in PowerShell speak, and then we're doing the clone, and then we're changing directory PowerShell wise into the KinD directory here. If you noticed, I can do CD as well. CD was working just fine for me, as you can see. CD into here, into this KinD folder. PowerShell will translate that, and then we just kick off with redeploy. So let's take a look at this repo a little bit more. First, I'm going to switch branches. So after we go into the directory here, we need to change to the PowerShell branch, otherwise we're not going to have the PowerShell files. So let's go ahead and do that. There's two ways to do it. You can do a command line, or if you're in a text editor like VS Code, you can do it right here. I'm going to do a command line now, but sometimes you'll see me go in here, so I can just click that, and I can just click the different branch I want to change to over here. So now we're in the PowerShell branch. Now we have more files available to us. Now you can see PowerShell. when you change it in kind, it'll change on the command line and vice versa because it's the file system of your actual session of the operating system there that's being modified. What Git is deciding to show you what files it's showing you. Okay, so the general makeup of a lot of the repos here in Tech Survival School is we'll have a deploy at the root here, like a redeploy. So the scope of that will be it'll tear down what it's designed to deploy. The redeploy will because it runs the teardown script and the deploy script, and then it runs the deploy script after it runs the teardown first is what it'll do. So what's in deploy? Well, in deploy here, we just have the command called kind create cluster. This command kind is going to talk to the local Docker runtime engine, container runtime engine, and provision the cluster. It's going to do Docker pull, Docker run commands, and it's going to bring the cluster online. After it gets the kube config, then it's going to dump it into the local kube config file location, which is in the home directory, which is depicted here in PowerShell speak, the home directory and .cube and config. Everything else is basically the same for Bash on a Mac. You'll just interpolate some of these PowerShell, and you'll see the equivalent over on the Bash side of this repository, or over on the Bash branch of this repository. Okay, so then after the kind is deployed, it's passing a config file. Let's go ahead and take a look at that. Now, if you want more information about kind itself, uh, gotta click on the right one here. You can go to the kind web page here, and then you can get all sorts of information about configurations, ingress, load balancing, and stuff like that. But it is not a glamorous, elaborate tool. It's meant to get you moving in Kubernetes quickly on your local workstation again, so we can test some things. So that's why I like it. The more advanced things we'll do when we're depicting when we need different clusters online, we need the networking solid so that we can SSH to each of the individual nodes if we need to, and something a little more comprehensive and easier to look at. We'll be using HashiCorp's Vagrant along with VirtualBox to deploy some virtual machines that we need, and we'll set those things up in as code, and then we'll get into working with the technology there. So, but we're just going to use this for something simple here. So let's go back to our code here, and let's take a look at this config file. So the kind config file, I don't need this up. The name of our cluster, we're just calling it multiverse. You can call your cluster whatever you want. You go and change that. This here, we're listening on all addresses here, and we're bringing up port 8443. We're using that port to communicate with the Kubernetes API. We are disabling the default container network interface that comes with kind. So if you're not familiar with Kubernetes, don't worry about that. We'll get into container network interfaces, a little bit of how they work, and what you need to pay attention to about them in order to be successful in what you're doing. Uh, but so kind, for example, comes with a default container network interface, what CNI stands for. We disable that, and the reason we do that is because we deploy a different container network interface called Calico. And the reason we do that is because we want to be able to use Kubernetes, things like Kubernetes network control policies. So if you deploy kind with the default CNI that comes with it, everything will work just fine. You're not going to have any problems. But if you're doing anything that you need to deploy Kubernetes network control policy, the default container network interface that comes with kind is not going to honor it, is what's going to happen. So you'll commit it, you'll deploy it, that manifest will be there, but the effect will not be realized. So everything will work. So if you need just like a basic network online and you're not going to do anything fancy at all or anything like that, and you just need things to work, you can just delete this whole line. You don't need to worry about that. Just another option here, what the pod subnets are going to have. You can just put that here, what the CIDR is that you want. Some of the other things to pay attention to here, under nodes here, so we can have So this is all YAML configuration. We'll have a different uh, video just discussing YAML and JSON and stuff like that later on. But we can list multiple nodes here. We can have a control plane. It'll have a different role like a worker or control plane. But the issue is we're not gonna, our networking isn't in a multi-node configuration. Our network isn't gonna have its own like virtual network interface. Uh, Most of our workstations aren't set up like that to where we can just add virtual network interfaces and stuff like that to make it very easy to show a um, multi-node local data center, if you will. So we're just doing one node. Okay, so all these videos we're just do one node. If we're gonna do multi-nodes, then I'm gonna be using Vagrant and VirtualBox to have a more accurate representation in terms of networking and all other kinds of stuff we're gonna want to show. Uh, so the role then is control plane. We're only gonna have one node. It's gonna be a one node cluster. Uh, we so everything we deploy is gonna go on that same node. So we don't need any more nodes than that at this time. The only other thing we're adding here is for the API server. So this is so that we can contact the API server on using the local host or using all the zeros here. So the thing is, if you're wanting to use KinD somewhere else and you actually have your own DNS, so like cluster west, for example. So if I deployed this out and I wanted to call this if I wanted to access the Kubernetes API server on this DNS entry, and I had a DNS entry here local pointing to the IP address that the Kubernetes API server is hosted on, then that's going to work. But otherwise, if that's gone and I deploy this cluster and then I create that DNS entry and then I try to access it using that name, the Kubernetes API server is not going to allow it. The they have to match. So we just use the local host there is what we use, and then we're fine with that. The other things of note here are that we have a number of ports opened up. And I'm just leaving these ports here and everything we're doing because it just gives us some flexibility. Like say for example, the only thing we were doing is we were deploying a kind Kubernetes cluster, and then we're going to throw one web application on there for Nginx on, and that's going to be it. It's just going to have one port, and that's it. Then we could just have one port here. We would just get rid of all these ports, and then we just have the one port. But I have these extra ports here, ports 0 through 6, and also 443, that can be used as a SSL port. These are the ports. The port ranges from Kubernetes is 30,000 to 32,000, I think, something like that, that you can have for Kubernetes ports going into here. So the issue is that after the cluster's up and running and we're deploying apps, we're creating services, we're punching holes in the cluster to access certain things we're deploying, we're going to need ports opened up here. So the reason why these are all listed here right off the bat is because we would have to essentially relaunch our cluster in order to add more ports is the thing. So we want these ports opened up so that we can use them. Okay, we may use one, we may not use any of them. We're going to use one as a part of today's deployment just to show you, but that's why these ports are here. So leave these ports here. If you need more ports than this, you're going to have to modify this file and then redeploy the cluster. Okay, but that's not that big of a deal. Okay, so that's about it for this config file. After we deploy it, we're just setting the environment variable called kubeconfig. We're setting that to the path. This is essentially the default path anyway that kubectl looks at. Use the kubectl command to apply the Calico container network interface. And what that's going to do is, we can just take a look at that. You can just paste this right into the browser and see what's in here. So this is a YAML file that contains everything that the folks that build Calico say needs to be on a default deployment of their product. So this will be everything from service accounts to deployments, pods, uh, roles, cluster roles, all kinds of things is going to be in here. So that is what's in that guy, and we deploy that. Uh, this used to be a thing. I think in the early versions of KinD, of Kubernetes and Docker, there used to be a setting here that you needed to set some, you need to tell Calico to ignore some looser, it says looser PF, something like that. So I've commented this out because this is no longer needed. It's been a number of years, and it was because of something to do with the way KinD was getting deployed and how it was setting up its networking. But now this is not an issue. So that's commented out. And then after we deploy the cluster, we deploy some basic monitoring and stuff like that. And the reason is because we use this tool to look at our cluster called Lens, and it's handy to get some metrics on this. This is a free tool. Mirantis bought it. You can go out to Lens, search for Lens Kubernetes, and you'll find it, and you can register it and download it. So we'll get more into that in a second. But we do like to get some statistics, some monitoring statistics, and then so we deploy a baseline Prometheus configuration for that. And if you're interested in what that looks like, the Prometheus values are right here. We're using two of those ports. Remember the ports 30,000 to 30,006. We're using two of them. One of them for Grafana if you want to access that. Another one for Prometheus if you want to access that. And then we deploy a sample app using Kubernetes here. So we just create one deployment. We're using this program. It's actually hosted at, I believe it's httpbin.org. Yes, it's still here. So you can go out here. You can, if you're wanting to test API calls and stuff like that, you can make calls directly to this website, or you can deploy this internally. And we'll use this image quite a bit to test things out. And then we have a service here. This isn't a Kubernetes specific video, but the service that's defined here, we're using NodePort 30,000s because we have, if you recall, we have 30,005 and 30,006 we're using, and then we'll deploy this, and we're just going to say this is a node port that's opened up on our local workstation, and then we can use our command line or our browser to connect directly to it. So we're deploying actually this application right here. We're deploying it internally. And here's the container image for it. Okay. Without further ado, let's kick it off. Like first says it's going to redeploy in our design for most of our automation we'll have. It'll run the teardown and then it'll run the deploy after that. So first it makes sure that it has the image, it pairs the nodes, puts the configuration on there, everything like that. Everything that you just saw right here was the Calico being deployed. But now the cluster's online, as you can see. So let's go to our lens, and then we can see that the cluster has appeared here because it's lens is automatically looking in our home directory, .cube, kubeconfig. Inside there is the context that KinD put in there after it deployed the cluster. And let's take a look at our pods. So right now, we are waiting for the Calico to come online. Am I still? No, I'm not still uploading. I was uploading something earlier, but okay. So now we just have to wait for it to come online. Okay, we'll pause the recording and wait for these pods to come online. Okay, we just had a hiccup in our internet is what the problem was. So we've now redeployed our cluster after we've fixed that issue, and we're just redeploying now. Let's go back, let's check our configs. Let's take a look at our pods. Watch them come back online here. And Calico's starting to come up. As soon as the Calico node comes online, DNS services will come online. There we go. Prometheus is deployed. It's waiting for the networking. There we go. Now, once Prometheus is deployed, you'll start to see metrics coming out of here. So right now, like we don't have CPU, memory, or disk for the single node that we have. But once Prometheus is running for a little bit, we'll be able to get that information. There's our cluster. Should be one more deployment. And this is our application coming online, the HTTP bin application. All right, there's our cluster. Let's take a look at it. We'll say, I think the alias should have been set. Let's test that out. The alias did not get set. I'll have to experiment with that. Usually like setting the alias K, we can say get nodes. So those are our nodes. Let's take a look at deployments in all namespaces. So there you see we have core DNS, the Calico kube controllers, Prometheus, and Grafana are all in the monitoring namespace. Okay. And lastly, let's go ahead and check. If you don't have the HTTP command installed, I recommend installing it. We're going to HTTP localhost. We're going to go to that NodePort 30,000, and then we're going to use the anything API. So we got back a 200 from our local cluster on port 30,000, and it spit back to us what we sent to it basically. So this is a good application to use for testing all kinds of API gateway or service mesh or anything like that. We're going to have a lot of fun using this stuff in the future. Other than that, there's really nothing else to the cluster because it's just a single node cluster. It's very basic. And so then all we're going to do now is we're just going to go ahead and tear it down. Like I said, the redeploy here, we'll tear it down and deploy a new one. We're not interested in that. What we're going to do is we're just say scripts. We're going to say tear down. And then it go ahead and just deletes the cluster. That's it. Thanks for watching, and we'll see you in the next video.